Thank you all for coming to my talk. My name is Arun Kumar. First off, a huge thank you to the TCDE Rising Star Award Committee for according me this honor. I am truly grateful and I will cherish it. And thank you also for inviting me to ICDE to share some of my thoughts with you. I'd like to talk about what I see as the new DBfication of the world of ML and AI. I call this saving them from themselves. So let's see what's that about. First off, I will talk about what saving I'm doing, and then I'll talk about why the rest of us in the database community should care, and briefly about how you too can step in to be a savior if you'd like. It's no secret that we now live in the golden age of ML and AI. All the big tech companies use it extensively. All enterprises are now pretty excited about it, and there's a huge demand for tools and products to make it easier to integrate ML AI with their data analytics applications. Even academic domains, domain scientists, digital humanities are excited. The International Data Corporation estimates that the market size for products that make it easier to use ML for such applications is set to hit almost $500 billion in the next few years. Now that figure is astounding to me, but that's what the IDC estimates. Now, naturally, there's a lot of activity in the open source world, a lot of excellent tools for integrating ML into your applications. All the major cloud vendors are coming out with new ML AI services. However, in spite of all this progress, as I will share about today, and as my research finds, there are still numerous fundamental efficiency and usability bottlenecks in the end-to-end process of building and deploying ML applications. And at the end of the day, that's what my research is about: new abstractions, algorithms, and software systems to democratize ML AI-based data analytics by mitigating such bottlenecks from a data management and system standpoint. By democratization, I mean precisely the following: improve system efficiency, reduce resource costs, resource use, monetary costs, and improve human efficiency, improve the productivity of the people involved in the loop. And this requires unifying and synthesizing the areas of ML and AI, but also data management, databases, data engineering, data systems, and straddling the entire system stack. More concretely, in my work, I build practical and scalable data systems for ML AI analytics, and these are inspired by principles of relational database systems that we have been studying for almost half a century now. And they exploit insights from statistical and computational learning theory and optimization theory as well, because these are at the root of what ML AI computations are about. I have interacted with data and ML practitioners in over 36 settings across enterprises, healthcare, web, domain sciences, and so on, to understand and abstract this end-to-end lifecycle of ML. And I characterize this as three main stages: source, build, and deploy. And in the source stage, the data science, ML engineers, and the other practitioners convert raw data, which could be multi-table relational databases, text corpora, time series, multimedia, and so on, into a form that is ready for ML. Then in the build stage, they do model selection, do feature engineering, algorithm selection, hyperparameter tuning, architecture selection, all of that, and then produce a precise prediction function or pipeline. And then in the deploy stage, they integrate that prediction function or pipeline with the application for predictions. This includes integrating into data systems, integrating into cloud native applications, and so on. And they have to monitor and maintain this whole life cycle as the data evolves, as the application evolves. The models must also evolve. Throughout this life cycle, they use data systems and ML systems for achieving their ends. And this includes all kinds of systems at all kinds of scales and all kinds of ML methods. In my own research, I'm largely ecumenical to what sorts of data systems and ML systems they use and what sort of ML methods they use. I like to focus on more fundamental processes and bottlenecks. More specifically, in my research, I like to abstract key steps based on these conversations and formalize the computation for them. And this includes both the data flow and the semantics. And then I automate the grunt work so that they can focus on getting value for their application rather than on grunt work. And finally, based on this formalization, we can now optimize the execution to improve resource efficiency by using techniques that we know and love from the database and systems world. So that's it about my research. If you're more interested in some of my projects and papers, feel free to check out my research group page. What I'm going to chat about next is briefly about why we as the entire community should care. The way I see it, ML AI systems and platforms today resemble relational DBMSs circa early 80s. And across the entire life cycle, there's a lot of fundamental open database problems. And this is why I call this the new DBfication of ML AI. For example, at the source stage, we need metadata management for ML, data preparation and cleaning, multimodal ML models for query models for unifying these sorts of data types, data search systems, data labeling systems. Across build and deploy stage, you need scalability. Scalable data systems are fundamental. Query optimization still matters for resource efficiency in these contexts. Cloud native systems, streaming systems for model deployment and prediction serving, all of that matters. And then across the whole lifecycle, you need provenance for tracking and debugging and governance and how to improve the application that uses ML. And there are overarching issues across the lifecycle, like benchmarking. what are the frameworks to think about the data management tasks in this context, to compare tools objectively, label data sets to understand and compare them. And this goes beyond data sets for individual ML algorithmic tasks like, say, ImageNet and Vision. And there are overarching issues of fairness, transparency, privacy, security, and so on that involve data management style issues. In my own research, for instance, I've been studying over the last few years issues of metadata management for ML, data prep for ML, and also multimodal ML systems. I've worked extensively on scalable data systems and query optimization for ML systems. And these techniques straddle all kinds of things, including multi-query optimization, join pushdowns, materialized views, incremental view maintenance, all of this for ML systems. And I also like to benchmark and compare ML tools, ML systems. And more recently, we are also building benchmark label data sets for a lot of data management tasks in this setting. Now, all of these are database problems. And if we as the database community don't tackle such database type problems, who else is going to do this? The ML AI community largely focuses on the algorithmics and the accuracy issues. They are trying to bridge the gap, and we also need to bridge that gap. Leaving these problems open will result in a huge waste of time, effort, money, energy, etc., by ML practitioners across the world. And this is a shirking of our intellectual responsibility as the database community if we do not study these sorts of problems, in addition to all these other problems that we focus on for all sorts of data models and query models. Okay, so hopefully I've convinced you that we as the database community should also study about these problems. Now let me share my thoughts on how you can also step in. I call this becoming a DBesque ML AI savior. And I base this on my own experience, so it's not comprehensive. First off, learn the basics of ML AI algorithms and theory. This is kind of like learning logic, relational algebra, SQL, if you want to work on RDBMSs. And the way I do this is review the algorithms classes for ML and AI at your institution or online. There are some excellent classes. Get excellent textbooks. These are 3 books that I like. Elements of Statistical Learning by Hasty, Tipster, and Friedman, Machine Learning by Mitchell, and Deep Learning by Kuval, Bengio, and Goodfellow. And there is also a need to know spectrum. You don't need to sit and read everything up front. You'll pick up stuff as and when you need it. If you're working on deep learning systems, learn about deep learning and stochastic gradient descent and so on. If you're working on accuracy trade-offs, then you need to know about the bias variance noise decomposition in ML theory. And so you can spread this out over time as and when based on the problems that you study. Second, and I know this is a talk by me, so there's going to be a little bit of shameless plug here. Check out my Database for ML course, the Data Systems for ML at UC San Diego. It's a graduate course that I put a lot of thought into. I have gotten thank you notes, I'm glad to say, from folks all over the world, Asia, Africa, and also in industry at Google for making all my materials available online freely, including lecture videos. So feel free to check it out, and I'm happy to receive feedback. I also co-authored with my colleagues Matthias and Jun this book on data management and ML systems, where we comprehensively characterized research in this space and also identified several open research questions. So feel free to check that out. More recently, in the last few years, we've had some excellent tutorials on DB for ML stuff at Sigma, DB ICDE, and all these venues. Here's a small sampling of them. Feel free to go check them out. There are videos and slides available online. Follow the references there for the papers to read and the open questions. And also attend the panel discussions on DB for ML stuff at these conferences. For instance, I myself ran one at the Sigma Dean workshop in 2018. The blog post that I authored about it afterward has been read widely. And heads up, I'm going to be chairing another panel discussion at Sigma this summer, and rest assured it's going to be an explosive topic. Be on the lookout for an announcement from me in the next few weeks. Attend these workshops, data management for end-to-end machine learning DEAM and human-in-the-loop data analytics, Hilda, and also check out this recent conference, MLSys, where a lot of interesting stuff is happening. But most importantly, apart from all this intellectual and academic stuff, speak and collaborate with actual practitioners, actual users of ML AI, build real stuff, and help transfer the stuff, the research and the tools to practice. And these practitioners are of all kinds: data scientists, data analysts, ML engineers, ML ops engineers, domain scientists. Create open source artifacts, both software and data, and work with some of these companies, enterprise companies, web companies, cloud vendors, or even just domain scientists in the academic world or policy folks to help transfer the research to practice. I also like speaking at industry venues, attending industry venues, some of these examples over here. A lot of practitioners show up to these, and this is a good place to advertise your work and also gain feedback from the practitioner world. And that's it from me. I'd like to thank all my terrific advisees here at UC San Diego. And these are the students that are the powerhouse behind the research that came out of my group. And I'd like to conclude: all code, data, and papers and talk videos are available on our project webpage. Go check out our group webpage. Feel free to follow me on Twitter as well. I'd like to thank all my research sponsors, and very special thanks to my database area colleagues, Victor, Yanis, and Helen at UC San Diego. It's the incredibly collegial, friendly, and supportive environment at UC San Diego, both at CSE and at HTSI, that has really enabled me to do all this work. And I'm really grateful to them for this. Not just my database area mentors, but also my ex-advisors and other mentors on this campus and elsewhere. So thank you all again for this. And thank you for attending my talk. Take care.